We want to find this integral of an absolute value of a quadratic function. Well, we don't have a very good way to find the integral of an absolute value of a function, so we're going to split this integral up into pieces. Let's take a look and see why. If we want to know what this function looks like, we might factor it and find that it has zeros at t equals -5 and t equals -9. Then if we graph this function, it's going to look something like this. We know that it's a parabola that opens upwards, and it'll be below the x-axis right here. And if I may extend this function a little bit further out here and continue to draw this function not to scale, I noticed that we are going to integrate this function from -19 all the way up to +5. So in keeping with my terrible drawings, there you go. So from -19 to -9, the absolute value of this quadratic function is just the function itself. The same is true for x values of -5 up to +5. The function itself is positive, so when you take its absolute value, it just stays where it is. However, if we were to integrate this given function without the absolute value between -9 and -5, that function would be below the x-axis. That would give us a negative value in our integral, but we're actually integrating the absolute value of this function. If this function is below the x-axis, the absolute value of that function would mirror that function above the x-axis. And when we integrate, we really want to get this positive area right here. So this area that I shaded in red is what we're trying to find with this absolute value integral. How do we actually find this area? Well, we have to split our integral into 3 pieces. We'll start with the integral from -19 all the way up to -9 of t squared plus 14t plus 45. This integral gives us this shaded region right over here. For this next region, we know that if we integrate this function from -9 to -5, because this piece of the function is beneath the x-axis, this integral is going to come out negative. But we don't want that negative area, so what we can do is actually just put a big negative sign on this term here. That'll make this negative area positive. Now essentially what we did right here is exactly how we define the absolute value of x in the first place. We say the absolute value of x is just itself when x is greater than 0, but if x is less than 0, meaning the function is below the x-axis, we have to put a negative sign on our function. Okay, so hopefully that makes sense. This last piece of area right in here is going to be the integral from -5 to +5. And that's the setup for this problem. If we can calculate this integral accurately, then we will be finished with this problem. I wish I had an easy way to do this, but we really just kind of have to grind through it step by step. One thing that I know is that each one of these integrals is going to be the same, just evaluated at different points. So every one of these integrals is going to be a 1/3 t cubed plus 7t squared plus 45t. This first integral is going to be evaluated between -19 and -9. The second integral has a negative sign on it still, and we're going to evaluate that between -9 and -5. And this last piece is going to be evaluated between -5 and 5. Okay, I'm just going to start writing some terms out. Now in the interest of space here, I evaluated this function at the upper limit here, and then I'm going to subtract what you get when you plug in the lower limit. Now for this next term, we're plugging in our upper limit of integration here. Notice that that has a negative sign on it here. And then the fundamental theorem of calculus tells us that we're going to subtract and plug in this lower limit of integration. Well, subtracting is going to take this negative and that negative from the subtraction and make that whole term positive. Now I think I need just a little bit more room here. This final integral, I'm going to plug in my upper limit. I'm subtracting and I plug in my lower limit of integration. Now this is only somewhat helpful, but you'll notice that this big term right here is the same as this big term right here. You'll also notice that this term here is the same as this term right here. Again, they don't cancel. They're both negative, but you only have to calculate this term once. Plugging each of these terms into my calculator is giving me that this term up here is -81. And plugging each of these into my calculator is giving me those 6 numbers. If you then combine each of these terms, keeping all the signs correct, I'm getting 32 over 3 as my final area of this drawn function over here. And therefore the final value of this integral of this absolute value. Okay, I think we can all agree that that was a little bit tedious. The piece of information to take from this problem is that if you're integrating the absolute value of a function, you can first find the zeros or the roots of that function. That's where the function crosses the x-axis. Then you have to split up the integral into pieces based on those roots. And wherever the function is below the x-axis or negative, that piece of that integral you have to put a negative sign on to make that area positive. Okay, I hope that explanation helps. But good job on this one, and I'll see you in the next video.